Hello and welcome back to Properties of Squares. Today we're going to talk about squares, what kind of properties they have, and how we can find missing angles and side lengths using those properties. In previous videos we have talked about parallelograms, rectangles, and the rhombus. These are some of the properties that all of those have. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. The rhombus has, and rectangles both have, the rectangle has 4 right angles, and the diagonals are congruent. And then today we're going to add in these 3 new ones that state 4 congruent sides for squares. It means every side is equal to itself. The diagonals are perpendicular. They make a 90-degree angle. So if you're not sure about that, make sure that you write this down, 90-degree angle. And diagonals bisect opposite angles. Okay, we're going to take a look at a few of those and learn how to solve them. Okay, I'm going to do numbers. Let's go to number 7 first. Okay, square PQRS is a square and side TR is 17. Find each missing value. Okay, so 17 is not on one of these larger sides. So what we're going to do is we're going to take a look up here at our different properties. Okay, so the first thing that I notice here is that the diagonals bisect each other. That means that each one of these are the same. Diagonals are congruent, bisect and congruent, so it splits it in half and they're all the same. Okay, now what that means is we can take this 17 and we can put it with all the other red hash marks. So if I'm finding PR is just 17 plus 17. It's both 17s combined together. Okay, so we add those together, we get 34. QS is right here. We're going to use that diagonals are congruent again. So if QS is a diagonal, it's going to be the same length as PR. So they're both 34. Okay, next up we have QT. QT is here on the inside. We said that all the red hash marks are the same length. So QT is going to be 17. The last one that they want us to find is PQ. Okay, so PQ is up here. Now for PQ, the only way that we're going to be able to find it is through the Pythagorean theorem. How do we know that we can actually use this though? Well, one of our new properties was that diagonals are perpendicular. So that means that they make a 90-degree angle right here in the middle. Okay, so we get a 90-degree angle here. There's one down here. You got one over here and here. Okay, so now we have a right triangle. This isn't just any right triangle though, it's a special right triangle. How do we know it's special? Well, both sides, or both legs of this triangle are equal. That tells us that it's going to be a 45, 45, 90-degree triangle. So we got 90 here because these two sides are equal. That makes this angle the same as this one. So 180 minus 90 is 90. Then if you divide that by 2, that gives you 45 degrees. So you got 45 here, 45 here. Now this brings up an interesting point. We have diagonals bisecting each other in the middle, and they also make the perpendicular angle. So all the angles in the middle for squares are going to be 90 degrees. All the ones in the corners are going to be 45 degrees. That's something that you're going to want to take note of whenever we move on down here to 8, 9, 10, and 11. Okay, so let's focus on PQ real quick. I can say A squared plus B squared equals C squared. My C is across from the 90-degree angle, so this side right here would be C. And then I plug in what I already know. So here for A I have 17. For B I also have 17. And then we set that equal to side PQ squared. If you wanted to replace the PQ with an X or just leave it as C, you could do that as well. I just like to put the PQ because it helps to remind us that that's what we're trying to find. We're trying to find side PQ. Okay, so if I do the math here, 17 squared plus 17 squared is 578. That's equal to PQ squared. Now you take the square root on both sides. That cancels these out. And what we're left with is PQ equals 24. Boom. Okay, now let's take a look at some angles. PRS. P, start at P, I go to R, go to S. Okay, that's one of our angles in this corner. Okay, what we talked about up here is that all the angles in the corners are 45 degrees. Another way that you could think about angles in the corners, remember that we said that the corners are 4 right angles. So we know that this is already 90 degrees. And then, if the diagonal bisects this angle, okay, that tells me that I'm going to do 90 divided by 2. So there's multiple ways that actually prove that these are 45 degrees. Alright, next up, STR. I start at S, I go to T, I go to R. Okay, so if I outline it, I get this one right here in the middle. We said that all angles in the middle are 90 degrees. PSR, that's this one. We're outlining the corner. That's a 90-degree angle. Comes from up here on top, 4 right angles. The last one, QPR, Q to P to R. Okay, we already labeled that one. It's 45. There we go. That's number 7. Okay, let's do another square problem. I'm going to come down here to 11. 8 and 9 are rhombi. We don't want to do those. We're only working with squares right now. Okay, so number 11. If FGHI, this shape right here, is a square, solve for x. So we're trying to find this angle. Okay, just a few quick things that we need to label. Remember, from problem number 7 up here, the angles in the middle are 90 degrees. And then we know that our corners are also 90 degrees, but the corners are bisected by the diagonals. So this diagonal bisects this corner, so that gives me 45 here, and that also makes this one 45. So what I have is that 7x plus 3 is in the same corner as the 45-degree angle. So I'm going to set them equal to each other. 7x plus 3 equals 45 degrees. Just solving for x. Opposite of add is subtract. So I'll do that to both sides. And I get 7x, these cancel out, equals 42. I got to get rid of the 7. I want the x by itself. So I divide by 7 on both sides. And my x equals 6. And there you have it. That's number 11.